Number one, what is electric potential energy? So it is stored energy an electric charge has in an electric field. And it's important to know how that works. So more energy closer to like charges. And therefore, less energy the further you get from like charges or the closer you get to opposite charges. So if you have a positive charge here and a negative charge here, you're going to have an electric field that looks something like this. So if I put a charge in this field, how much energy it has is the electric potential energy, and it's P little e. P little e. Okay, so number one, electric potential energy is stored energy a charge has. Okay. All right, electric potential. Stored energy. A particular location has in an electric field. So, it's not how much it's not how much energy a charge has, it's how much energy a field has. So, same thing, here's my positive, here's my negative, creates a field between them. And I've got my location here, but there's not a charge there. So I don't know how much energy the charge would have. I just know how much energy the area has. Like, how much energy does this spot have? Okay? It's similar to electric fields compared to electric forces. Electric forces is what's the actual interaction between charges. Electric field is what's the area around a charge that would feel a force. This is what's the area in a field where there would be energy. So how much energy would there be? And there's more energy the closer you get to positive charges and less energy if you get further away, assuming we're thinking about positive charges. Okay? So it's stored energy. Again, it's similar to the difference between electric field and electric force. Okay, so electric potential energy is how much energy a charge has in a field. Electric potential is how much energy the field has in general. So it's not specific, it's just in general. The third one is electric potential difference. It's the difference in stored energy between 2 points in an electric field. Okay? So it's the difference in energy between two places in the field. So same thing I've been drawing, positive, negative, field. But I want to know the difference between those places. So this one just wants to know how much energy is here. This one wants to know what's the difference in the energy. So what's the difference in the energy between those 2 points? Okay, any questions between those 3 things so far? Because they're very similar and yet very different, and it's important to know the difference between them. So electric potential energy is how much energy a charge has. Electric potential is how much energy an area in the field has. And electric potential difference is the difference in the energy between 2 positions. Okay. One more. What is voltage? Voltage is an easy one. You're welcome. Voltage is the same as electric potential difference. And it's measured in volts. So we were basically saying, hey, electric potential difference is really complicated and there's a lot going on. Why don't we make it something simpler? Okay, let's call it volts. And that's what it is, voltage. So voltage comes in effect with batteries. So you have a battery that's got a positive side and a negative side. The potential difference, the voltage, is 1.5 volts. What that means is the difference in potential between positive and negative is 1.5 volts. So when you see a battery and it's a 9-volt battery, the difference in voltage between the left side and the right side is 9 volts. That's the difference in the electric potential energy. The electric potential difference. Oh my gosh. Who set an alarm? Nope. Yeah. Oh my gosh, it's always something with Physics 1. You can't trust those Physics 1 kids.
That's what he was saying
Huh?
about us last year.
Yeah, it is what I was saying about you last year. That's right.
I had Mr. Rohrbach.
Yeah. That's right. He says the same.
We got the good teacher.
Yeah, that's right. Yeah. He was the teacher of the year. I'm fine with it. So here's the real question. The real question is number 5. Ugh, why does any of this matter? So why am I going to all this trouble to explain all these things? Why go through all this stuff? So we need to know how much energy an electric field has. But we don't always know how much charge there is. But the charge doesn't really matter. We just need to know how much energy a field creates. So we need to know how much the electric potential energy changes and that's this, the electric potential energy. We need to know how much that changes by but we don't always know charge, which is electric potential. So we use voltage. We don't always know how much the electric potential energy is, but we need to know the difference. So what we do is we figure out how much the difference is between the areas in the field instead of the specific values. Come on, big guy. All right. So, we've talked about electric potential energy. So, electric potential energy is the stored energy that you have. We talked about electric potential, which is the energy a spot has. We talked about electric potential difference, which is the difference between those spots. We talked about voltage, which is the fancy name for that. So, let's get an analogy that's going to make this a little bit easier. Something you're used to, something you're familiar with, and that is gravity. So, here's the Earth. Here's you. Yep. Got a little eye patch. You're a pirate. Chase is a pirate. He's got an eye patch. Here's his pirate hat. Here's his parrot sitting on his shoulder. That's totally a parrot. Anyway, so here you are on Earth. Okay. So the gravitational potential energy, which you're used to, we talked about, that's Pe little g. That is similar to your electric potential energy. Okay? So that's how much energy you have at that point in space. Okay? So how much energy is just in general on Earth's surface? If I don't care how much energy you have, I just want to know how much energy the Earth creates. And I just want to know how much energy is here. That's electric potential. That's electric potential. And if I want to know, what if I climb a ladder, how is my energy going to change? So here's my stairs, because I can't draw a ladder very well. So if I climb up the stairs, and I want to know how much does my energy change by. So the difference in energy. That's the electric potential energy difference or voltage. Okay. So we got all these things that are in our brain now. Does anyone have any questions? Oh, I better stop this before YouTube gets mad.